Okay, then welcome everybody to my talk. It's all about the domain, honey. I hope you can see my slides, and there is a Q&A here in the session. So if you have questions or if you want to give me feedback, please use that medium. If you ask questions there, then I will answer directly if I see it, or maybe in the end of the talk. And you should also see a link there that I posted. So if you want to look at the slides afterwards or during the talk when you want to go back or something like that, then you can find the slides there. Okay, it's all about the domain. And okay, now you may hear my baby daughter that's crying in the other room. The topic that I will be talking about today is domain-driven design, or as we say in the internet, hashtag #DDdesign. And I will tell you about it. Who am I? My name is Henning Schwentner. I live in Germany, in Hamburg, or Hamburgo, and I'm a programmer and a proud dad. And I work as a coder, coach, and consultant at a company that's called WPS. So as you can see here, when I'm lucky, I get my hands on a keyboard and can write programs, what a programmer usually should do. But as you all know, you make more money if you go to the right here. So most of the time currently I work as a trainer and as consultant. So I'm doing what I'm doing with you now. I'm sitting or standing in front of people and tell them how to do it right in software development and software architecture, or how I think that this is right. And as a consultant, I work with many different teams. The big problem that most of them have today is they have a big monolith. They have a monolithic system, a big ball of mud. And they want to split that up. They want to build a more modular software there. And that's what I help them with. So splitting monolith is a big topic that I'm working on. So if you have a monolith and need help, then after this talk, you know how to call. And what's a great joy with these monolithic system is that you can see many different technologies there. So many Java systems, many C# systems. Both languages are very well suited to build monolith. But as you can see here, many different technologies as well. One programming language is missing that should be up here. That's COBOL, of course. That's the language that you're still. That's well still the best language for building big balls of mud. Okay, as I said, I work for a company that's called WPS, or Workplace Solutions. We're the one with the touch table. And now for the content, domain-driven design is our topic, and domain-driven design means we design our software, we build our software, our architecture with the domain in mind. What's the domain? The domain is where our users are working. So we're not building software in outer space, we're building software for a particular purpose, and that purpose comes from our users, from our domain experts. Okay, so what is in the box? Eternal wisdom is what I would like to show you. Eternal wisdom is also what maybe we will question here in this talk a bit. And for starters, I will tell you about a particular domain. I will tell you a little story so that we can see what domain-driven design means with a concrete example. As you can see my father here telling a story, I'm going to tell you a story. And since I live in Hamburg, which is a port city, which is a harbor city, is a story about seafaring and how is seafaring today. Seafaring today is, as you can see here, container shipping. So this container here is loaded onto this big container ship here, the CMA CGM Magellan. And that ship is loaded here in Asia, in Shanghai, and then the ship travels around half of the world to the port of Hamburg. So this is our new signature building here in Hamburg, the so-called Elbphilharmonie. And the ship sails without big problems through the Indian Ocean, through the Suez Canal, the Mediterranean Sea, and finally arrives in the Northern Sea. And then it comes to a problem, because the final harbor, the port of Hamburg, is not located by the sea, but you have to sail up a river from the Northern Sea here, from the river mouth, to come into the port of Hamburg, into the harbor. So as you can see here, this is the port from above, the harbor from above. And this harbor is a sea harbor, yes, but not located by the sea, but by a river. And as you can see here, this river, the river Elbe, is it called here? That's the name, Elbe. This river has properties that are, well, problematic when it comes to container ships. The one property is that the river is narrow, much more narrow than the wide and open sea. And even more problematic is that the river is shallow. It's not deep. So that's both the opposite of a big container ship. A big container ship is wide and a big container ship is deep. It has a great depth. So you don't want to run on the ground with this big container ship. And as you can see here, it's quite a long distance, about 100 kilometers. You have to sail up from the Northern Sea here into the port. And of course, that raises the question, how is that supposed to work? Can that work at all? And the first answer is no way. The ships are too big. This won't fit. But that's only the first answer. The second answer is no, there's a special authority here in Hamburg. They are taking care of this, of getting ships into the port. It's called the HPA, the Hamburg Port Authority. And this port authority does everything that has to do with the port here in Hamburg, and especially they have one department that you can see here. It's called the Nautical Center. In German, Nautische Zentrale. And in this Nautical Center, well, you can imagine that a bit like the tower at the airport. The tower is coordinating when can aircraft start and land, and on which apron position do they come. And here in the Nautical Center, they coordinate when can ships come into the harbor, sail out of the harbor, and on which booth do they come? Which berth do they come? A berth is a place where a ship can lay when it's in the harbor. And what the guys that are working there are doing is, before they really get a ship into the harbor, is they simulate the maneuver of coming into the harbor. So we don't get, we don't tell a ship just come into the harbor, but we are using exactly the same maneuver that is going to be carried out in real life, and try that out in a simulation. And simulation, that's a big word. In the first traditional way, we're doing the simulation on a big piece of paper with a so-called sounding chart. You can see that here. Oh, sorry. This big piece of paper, this sounding chart, or depth map is another word for that. So a map with a depth on it. You can see here, there's something colorful in the middle. That is the river. And then there's gray stuff here. Those are the buildings that are standing at the riverside. If we zoom in, then we can see that the colorful stuff that we can see here, those are numbers, so-called depth numbers. So at this point here, we have 11.5 meters from the top of the water to the bottom of the river. 11.5 meters here, 11.5 meters there, that's 11.4. You get the idea. And you can see there are different colors here, and there are depth contours, these lines here as well. And the shallower it gets, the less deep it gets, the more red these numbers turn, to show, well, that's a problem. So this depth map is a good thing to, sorry, is a good thing to show and find a route that a ship can take to come into the harbor. For example, if we have a ship that has 10 meters depth, then we can see this can easily go here in the middle. And of course here it cannot go because there we have only 9 meters or 8 meters of water. That would be too shallow for our ship. So the nautical center, the nautical officers that are working there, they are finding a route, and then they tell this route to the captain of the ship out in the harbor. And that is working as long as we have these numbers here. And of course, these numbers, they don't just fall out of the sky, they have to be measured. And there's a special infrastructure here in the port of Hamburg with so-called sounding ships. You can see them here. Deepenschweber, that's Northern German for depth rider. And that's what they do. They ride the depth. They sail through the harbor, they measure the depth with an echo sounder, and then they ride this depth and send this depth into the headquarters of the port authority. They're in the headquarters of the port authority. They take all these depth data and numbers and calculate the color and these contour lines that you have seen, and in the end they draw this depth map here. And this depth map is then sent to the nautical center where they're doing the simulations. So as you can see here, these depth maps are stored away in these map cupboards that are standing around there in the nautical center. And when a ship arrives, a container ship arrives in the river mouth, then it asks for a route. Our nautical officers and the nautical officers then take their big piece of paper, their depth map, out of the cupboard and put it onto the map table. And then they take scissors and cardboard. That sounds a bit funny, but they're really doing it. And cut out a silhouette of a ship that you can see here that has the same silhouette as our ship out there in the river mouth. So important is that it has the same scale as the depth map, of course. And then it can be easily used to find a route to do this simulation, because you can now move and turn this piece of cardboard around on this piece of paper. And you can see, well, if we stay with this 10 meters depth, this is too shallow here. We cannot take that route. That would be okay, 10.5 meters, 10.2 meters, that would be okay. And maybe if we just move a bit to the south, then we can do our maneuver. Okay, so this is our domain. We are in the harbor. We want to get ships into our port, into our harbor, and we're doing simulations. I'm going to tell you this story again in another way. And we start with a blank sheet here. And the first thing that we have is the sounding ship that's measuring the depth. And the second step is the sounding ship sends these measured depth to the cartographer who's working in the headquarters of the port authority. The cartographer then will calculate the contour lines out of these depth numbers and finally draw the depth map with these depth numbers and contour lines. And this drawn depth map, the cartographer will send to the navigating officer, the people that are working at the nautical center. And now, if a captain of a container ship asks us for a route, or asks the navigating officer for a route, then the navigating officer will get out his depth map and cut out the ship silhouette and move and turn around the ship silhouette to find a route for the container ship to come in the harbor. And that route will be discussed with the captain. so the captain knows this is how I have to do. This is how I can come into the port, into the harbor. What you can see here, that's a so-called domain story. Coming out of domain storytelling. What's a domain story? The idea of a domain story is that we let our domain experts, our users, tell their story from the domain, and while they are doing it, we record this story in a simple graphical notation, in a pictographic language. That's what you can see here, icons and arrows. And the idea is that while the story is told, while our domain experts are talking, we can mirror them, we can reflect them. This is what I have understood. Then we can ask, did we understand you right? And our domain expert can say, yes, you understood right, or no, we have to change this step or that step. Okay, domain stories. A possibility to understand the domain, and then, of course, to build software for that. That's, of course, the next question. It's nice that they have these piece of paper stuff and all these, we cut out cardboard and so on. But of course, I assume you are, as I am, developers. And of course, we ask ourselves, is there an app for it? And I was lucky to be in the team, to work on the team that built the app that finally replaced this old paper method. And what you can see here is this new app below here on a big touch screen. And up here, you can see the old solution, the old paper solution. And what we can see here is what domain-driven design means and what domain-driven design is all about. The basic idea is we want to understand our domain, to understand what's happening in our domain, which work objects we have in the domain, and then take all this stuff and put it into the software. And there, in the software, we're making it better. So we start with what you can see here, this big piece of paper, the depth map. And we put that into the computer. So you can see here in the app and the application, we still have a depth map, which is also called depth map. And there's depth numbers on it. You can see here, like there were numbers there. And they are still colored and all this stuff. So the user of the old paper system will also may also easily use the new IT system, because it's basically the same. We have the same mental model for our users. And as I said, of course, when we put it into the computer, we make it better there. So what we can see here is the piece of paper. When we get to the edge of that, we have to put that depth map away and get another depth map out of the cupboard and see, okay, now we're continuing here. We don't have to do that in the computer, of course. We just can swipe, and then, like we know it from Google Maps or similar software, the map just will move on. Also, here we have a lens to make these numbers bigger. And we have something similar here. We don't need a lens anymore. We just can zoom in with a pinch gesture. And we just show the numbers bigger, like the lens is doing, but we are showing more details. We're showing a bigger grade of detail. When we zoom in, we show more numbers. When we zoom out, we show less numbers. So we can now go on different levels there. Also, the ship silhouettes, as you can see here, this piece of paper, are moved to the software. We can see it here. And the ship silhouette is still used with the hand, but this is also made better. As you can see, it's somewhat transparent, so you can see through that silhouette and see the numbers that are below the ship. Also, these silhouettes now turn red when they come into an area that is not deep enough. So again, what we are doing is we take the work objects from the real life and put them into the software. We take the actions that are done to these work objects and put that into the software. And we learn the language and put that into the software as well. And as you can see here, we are doing that on a UI level, on an interface to the user level, but we're also doing that on an architecture level, on a code level. So we want to have all this stuff, the work objects, the language, the actions, and also the structure of the domain. We want all this stuff also in the code, in the software architecture. So here's the video. The new systems is supporting the work like the old paper system was doing. So the nautical officers still have to move around these ship silhouettes. The next step would, of course, be that the nautical officers won't do that themselves anymore, but there would be an AI or an algorithm moving this stuff around. But that's not easy. That's not easily done because you have to have a lot of nautical domain knowledge to really do this simulation. That's why this is not done yet. Okay. Are there questions so far? I think there's only from the moderator the welcome message. So if you have questions, please post them into the Q&A here in the Teams session. Okay, so this is my example. Now I've shown how DDD is meant. How do we let our software be driven from the domain? And how was it when we started with this project? So we were a couple of developers. The cyber was strong in us. And of course, we asked ourselves the most important questions first, or what we considered the most important questions. And that was, which programming language are we going to use? What operating system will our program be running on? And what are the newest frameworks, and what are the newest versions of the newest frameworks, and how can we use them in our software? Plus, below that software will probably be a database. Does that have to be a classical relational database, or can it be something more new, like a NoSQL database, MongoDB, CouchDB, something like that? Those are interesting questions, of course, and technical people like us, they love to ask these questions, but what do these questions have to do with what we were talking about earlier? Has any ship come to the port because we made a decision? We said we're doing C# or we are using Java. Well, of course, no. Those are technical questions, and I have to tell you a sad truth here. I don't like it myself as well, but software is not an end in itself. So we're not building software for itself. We're not building software for us. We're not building software for technical beauty. Of course, technical beauty is something that will help us support our domain, but that's not the goal in itself. Software is not the goal in itself. Technical beauty is not the goal in itself. The developers, well, making the developers happy is not the goal of the software. So what is the goal of the software? The goal of the software is to support our domain, our users. Those are the most important people in this process. So what we want to do is make the work of our users easier, faster, more efficient. Make the work better. That's our job as software developers. Developers develop software, of course, but the software is only a means to an end. The software is not an end in itself. It's always the goal. The end is to support our users to make their life, their work easier. And DDD tells us how to build software like that. And the basic idea is that we don't build the software out there in outer space, but that we let the software grow out of the domain. So the software should put its root deeply into the domain. There's a close contact between domain and software, and the software comes and grows out of the domain. So we want to build the software as a reflection of the domain. Reflection of the domain, we saw that earlier, what that means on a UI level. So we want to take all these work objects, you know, the depth map and the ship silhouette, and put that into the software, and the language and the actions as well. We want to put that into the software. Okay, so we built the software as a reflection of our domain. And we're doing that on a UI level. We also do that on a code level, on our architectural level. And to do that, of course, we have to understand our domain. So we have the domain, we have to understand that, we have to bring the domain into our brains, and only then can we start programming and bring it to code. So this is an important point, because if we're not doing this arrow left here right in a good way, then no matter how good we are at this arrow right, we still won't build good software. Because even if the software is a technical beauty, it will just not fit the needs of our users. Of course, this arrow is important. But what many of us developers often forget is that this arrow is as important as well. We have to understand what's happening in the domain, and only what we understand or what we misunderstand will in the end be part of our software here. And that means we have to talk to our domain expert. So we cannot build the software without domain knowledge, and we can of course not build domain knowledge without talking to domain people, to domain experts. Here you can see a domain expert doing work, and here you can see the reflection. That's what we're going to do with the software, reflecting the domain expert's work in the software. And I look into the queue and into the questions again, and I see there the question, how do you choose a domain expert? Well, that's a good question. And usually you want a domain expert, somebody who's really doing the work. So in this example from the harbor, we want a nautical officer that is really doing all these simulations. That is taking out the map, putting a ship silhouette on it, doing it as their daily work. Also interesting can be what their managers or their bosses tell us about them or about their work. But this often can be how they think the work should be done, or how the work was done before they got promoted. And what we want to know is the real domain knowledge, so we want to have domain experts that are really doing it. Plus, it's also usually interesting to have more than one domain expert, especially when you're looking at the big picture. So in this example, we would want to talk to a nautical officer who is doing the work. We would probably also talk to a captain of this ship and to a cartographer as well. So all these actors that we found in the domain story, they are all candidates to be domain experts we want to talk to. Okay, and then there's another question from Stefano. With the data in your possession, does your app manage to create an automatic route for the ship? I'm just curious. Currently not, but that will be one of the next steps, there will be an automatic creation of the route, but still it will not be automatically sent to the container ship captain, because you need so deep knowledge of the nautical properties of the river, that in the end always a human has to decide, is this a good route or not? This cannot be done automatically yet. So the next step will be the system will make will calculate a route and tell the user, the nautical officer, this is what I think would be a good route. What do you think? And then the nautical officer will say, yeah, well, this may work or this may work not. Okay, so we see we have to all get into the domain knowledge. We developers have to become domain experts ourselves. Of course, not as deep as the real users, the real domain experts, but at least for the part that we are building software for, we have to get a deep understanding. And how do we get there? How do we get this deep understanding? There's one thing that DDD is relying on, that's the so-called collaborative modeling. That means we build a model of the domain, and we're not doing this alone, not only developers, but we're doing this together with domain experts. So we can see here us, the developers, and them, the domain experts, and we are brought together and we're working on it together. And we're crunching on the knowledge together. That's the DDD word for that. So the idea is we're chewing on the knowledge, on the domain knowledge, to get the juice out of it, to get the essence out of it. And for this collaborative modeling, there exist different methods. One method you may know or may have heard about is event storming. Was invented by an Italian DDD expert. So I think the probability is high that you have heard about it. Alberto Brandolini is his name. That's a method where you use sticky notes, and many different domain experts and many different developers can stand about a big wall and model together. And another method that I showed you earlier is domain storytelling. Domain storytelling is a method, this method with the stick figures and the arrows. And there are other methods for this collaborative modeling as well. Important is the basic idea that we're not doing it alone. We developers are not building domain knowledge alone, but we learn the domain knowledge from the real experts, from the domain experts. Okay. And another important topic there is language. And I think you hear my daughter again. She also wants to try out her language. And language is an important topic for DDD, for domain-driven design. We want to understand the language of our domain experts, the domain terms, things like depth map and all this stuff. And we want to bring that into the software. And what we want is a common language between domain experts and developers. And as you can see here, we want that this common language is based on the domain knowledge, on the domain language. So you can see the speech bubble here has the color of the domain expert, not the color of the developer. Because we want to learn what a depth map is, how a maneuver is simulated, how to move and turn a ship silhouette, and how to measure depth. And we don't want our domain experts to tell what a class is, what a method is, how a variable works. So we want to learn the domain language. We want to get the domain language in our heads, and we want to use that language everywhere. We want to use that language even in the code. So we don't just want to use the words on the UI of our program. We also want to use the domain words in our code. So there are different languages, of course, in every project. There's technical language that we use. Please deploy the container. I create an interface for that. Can I push it to the feature branch? And this technical language is not well suited to be used in communication with domain experts. And as I said, we want to learn the domain language. Or as we say in German, Fachsprache. And talking about different natural languages, domain language is often not English language, but in this port example, since it's a German port, there may be German words. Or if you're working in an Italian domain, there may be Italian words. And sometimes it makes sense to translate them into English, but more often it doesn't make sense. Because often information gets lost when you translate words. And then it's better to use the language, the words that our domain experts really understand, and that's often their mother tongue. So Italian in your example. Here in the harbor, silhouette, scale on the silhouette, depth, marking, depth map, those are all interesting words. But not only nouns are interesting, but also verbs, and especially verbs are interesting. So we want to know that the ship silhouette is moved around, and we want to know that this depth is computed. And also other kinds of words are interesting. An adjective like this marking is in neon yellow, or an event like this ship is run aground. So different kinds of words are interesting for us. So we have these different languages, and we're saying we want to have a common language, and that common language is based on the domain language. And we want that because we don't want this to happen. When the Tower of Babylon was built, God sent the different languages to the people and they couldn't communicate with each other. We don't want to have that here. So that's why we build a common language based on the domain, not based on the technology. And DDD calls this a ubiquitous language. That's a somewhat strange word, but the idea is very good. The idea is use the same words everywhere ubiquitously. Use the word depth map, use the word calculate and a depth number everywhere. So I don't know if there are some Germans here, and this is how you would pronounce that in German. Okay, when we look back onto our domain story, then we can see there's a lot of domain language. Or to be honest, there's only domain language in it. There's no technical language in there, and that's good. That's what we want to know. We want to focus on the pure domain stuff. That's why we call this domain story that we can see here a pure domain story, because we don't have any technology in there. No IT systems, no IT language. We want to start with the problem first. We want to understand what's happening in the domain and only then move on to put it into the computer. So depth map is an important word. We've seen that, and that means we want to use it everywhere. Ubiquitous language. That means in spoken language, in written language. When we draw diagrams, everywhere we use this word depth map. And finally, in the code, we will use this word again. So we will have a class depth map here. Yeah, everywhere we're using the same words. That's making a ubiquitous language there as well. So we're taking the words from the domain and putting them eventually into the code. And that's something good. Maybe you know this quote from Phil Carlton, who said, there are only two hard things in computer science: cache invalidation and naming things. And well, DDD doesn't tell us about cache invalidation, but it tells us about naming things. It says, don't invent your own names. Take the names that are already there. The things are there, the names are there, take them from the domain and put them into the computer, into the software. Okay, that's the topic, ubiquitous language. Now to the next thing, DDD in the small. As we have seen, we want to use the language in the code. And how do we build our code? How do we build our code model? How do we model our domain in the code? modeling in code is the word that we're using there as well. So the basic idea is take the work objects, take the things that our users, our domain experts are working with, and put them into the computer. So if we have a silhouette, and that's an important concept, then we build a class silhouette for that. So the things, they turn into classes. And then the next step is, let's see what is done with these things. A ship silhouette, for example, is moved. Then we say, okay, the actions that are done to our work objects, those become methods in our model. So we put a method move by a length into our silhouette. And another thing that's done to our silhouette is it is turned, and we make another method out of that as well. So we have two methods, moved by a length and turned by an angle. And what we get here, that's a so-called domain model with rich domain behavior. Rich domain behavior because we have domain language, the ubiquitous language here, silhouette, moved by, length, angle, turn by, all words that are coming from the domain. And we have also domain behavior. The silhouette can only do what is also possible in the real world. And that's something good. This model is expressive in the sense that it expresses what's happening and what's possible in the real world. So this is an example in Java, but of course this is working in every other object-oriented language as well. And you don't have to do it object-oriented. You can do it in a functional way as well. Then you would build a type for silhouette and functions for move by and turn by. Probably I should show the example in C#. I think most attendees are C# developers. Is that right? Maybe someone puts a C# in the Q&A and then the others upvote that. But of course, C# and Java, they are so similar. I think it's not a problem to come from one to the other. Okay, so now we have this nice ship silhouette. We have this rich domain model with rich behavior. And what you also may have noticed is that we started with the interface. So we only showed the signature. I go back here. We only showed the signature, move by, and no implementation yet. And that's something good. From Erich Gamma, from the Gang of Four, we know we want to program to an interface, not to an implementation. But of course, finally, we want to do an implementation. And how is this implementation done? If we think about moving around and turning a ship, probably in the end, that will just change the position of the ship. So why don't we do this here? Why don't we just put a setter for this position on the silhouette? You see there's a big red X here to tell you that's not what I think is a good idea. And in C#, of course, we could do it like this with a property that the position can be set. And again, this is the same idea that we have behind that. And I think it's not a good idea for several reasons. Why is this problematic? At first glance, this does look like a domain model. We have domain language here, a class name that's coming from the domain, but we don't have domain behavior. We only have getters and setters. That is, we only can change data. And this class now cannot anymore check if this position is right here. That's something else when we're doing this here. Move by, turn by, the silhouette class now can check, are the prerequisites of move by and turn by matched, and only if they are matched, then we move on, and else we throw an exception or something like that. So this model here expresses in a better way and is safer than that model here. Still, these kinds of models are pretty frequent. They already have their own name. That's the so-called anemic domain model. It looks like a domain model. It looks like we would model the domain, but in the end, we're not modeling the domain. We're not having behavior. That's why it's anemic, without blood. And the warning here is beware of setters in your domain model, because setters in your domain model, they cause model anemia. Getters, that's something else, but setters, be careful with that. Better it is to have methods that have a real name from the domain that represent an action that is done in the domain. Okay, so how do we find a domain model when we go back to our domain story? There's this rule of thumb. We take the work objects, like the ship silhouette and the root here, and turn them into classes. And then we take the activities, that's what we put on the arrows here, and make methods out of them. And that's more or less it. It's so simple it is. Well, of course, you have to build the right domain stories, and you have to work on the language and learn the language, but then you can derive a domain model. That's good. Okay. Okay, now before we come to DDD in the large, are there more questions? Then please put them into the chat, and I will have a look at that. Okay, I don't see questions now, but please, if there are coming more, yeah, please write them into the Q&A. I will again have a look there. Okay, then now that we know how to use DDD in the small, we're learning the language. We are learning which are the work objects, what are the actions done to these work objects, and we make classes out of them, we make methods out of them. Let's look at DDD in the large. That's something that's helping us for this, what I was talking earlier about, structuring your monolith, structuring your big ball of mud system. And to talk about DDD in the large, we have to make a step back and look at the world as a whole and see that is an interesting question to ask. How do we understand this world, and how do we get this world into our brain? So how does this arrow work here? How do we get this world into our brain? And as you can see here, the world is much bigger than our brain. And fun fact, in real life, there's a much bigger difference than on this slide. Anyway, we're still able to wrap our head around the world, to understand the world, although it is much bigger than our head. And why is that possible? That is possible because we as human beings are able to abstract. That means we only take the essential properties out of the world and put them into our model. And the inessential, the accidental properties we leave out. So we only take the essential stuff and understand that, and the essential stuff that's much smaller than all the stuff there. Another way to put this, or another word to put this, is we're building a model. We're not understanding the world itself, we're building a model, and then we understand that model. So a model is an abstraction that only contains the essential properties of the world, or of the thing that we are modeling. And now I said we need only essential stuff in this model, but, well, what is the essential stuff? That's an important question, of course. And the answer is, it depends. In different contexts, different properties are interesting. And that's why we build different models from the world for different purposes, for different contexts. One model of the world is this globe here. One of the properties that's essential for this model is that the world is turning. It's modeled here. Another model for the world is this map here, and there are other things essential. So this map does not model that the world is turning. It's not put inside this model, but we can see how the world is looking like from the outside. Where are the continents? How are they named? And stuff like that. And here there's another map, an atlas that's a collection of models of maps, and all different models for the same thing. So we are building not just one model from the same thing, but we're building different models from the same things. And now coming back to software or software development, the idea of strategic design of DDD in the large is to say we're doing the same with the domain as well. So we're not building just one big model, but we're building several models. And you remember, model means domain model in this sense, and domain model means in the end classes and methods. So we don't just build one big class for the world. We build several classes that are all called world in the different contexts. Well, how is that done? And first of all, I'd like to cite the late Karl Lagerfeld, who said something important here. He said, whoever uses the one big, the canonical model for the domain has lost control over his life. Now, well, he said something about sweatpants. Not so sure about that. So this is how he said it in German. So what we want is not build just one model. We don't want to lose control over our life or over our projects. We want to build several models, and we want to put boundaries between them. Well, they don't have to be as strong as here, not as hard as in Berlin in the Cold War, but still we want to be them pretty tough boundaries that are not easy to cross. And we want to separate the domain models from each other. That means this domain model should compile without that one and that without this one. And when we're doing this, we're taking the domain, this cow here, and we're cutting this into pieces, into smaller pieces, modules. And these smaller pieces, they are boxes. Every box contains a model on its own. And these boxes, they are called, in DDD speak, a bounded context. That's again a strange word, I know. Why are they called bounded context? Well, bounded because there's a boundary around them, and context because that's the context that a model is existing in. A model always exists for a purpose, always exists in a context, and this is the context that this model is existing, the bounded context. So a somewhat strange name for an important and not too hard to grasp concept. So how do we come to these different models in the software? Well, we look at domain stories again, and we see this big domain that we have here. Can we cut that into these smaller pieces? Can we take this big domain and see the subdomains in this? And I would argue there is one subdomain down here where the steps 1, 2, 3, 4 belong into, and maybe I would call it depth measurement. And then we have another area up here that I would call maneuver planning. So different areas in the domain, different subdomains. And the idea of strategic design now is to say, well, let's not build just one big model here, one big monolithic software, one big ball of mud software, but let's build two pieces of software, two modules here, one module depth measurement and one module maneuver planning. That's what we want to do. Not build one big monolithic software, but a more modular, smaller software there. Okay, that's the basic idea of strategic design. Avoid this here, the big ball of mud, the monolith, or as we put it, the horror. We want to avoid that. We want to get rid of the monolith, get rid of the big ball of mud, and we're doing this by building several models of the same things in real life. And we remember, model means we build classes and methods. And what's a tough thing to digest first is that means that we may have duplication over context boundaries. Because we build one small model here with depth, contour lines, and depth map. And we build another small model up here with ship silhouette and route and depth map. And there's words that are only on one side, the ship silhouette here and the route, they're not in the depth measurement, but there are also words like the depth map that are on both sides here. And they are, of course, a problem because we don't want to build just one big model, one big class depth map, but what we are going to do is build two classes of depth map. One class depth map in the package maneuver planning, one class depth map in the bounded context depth measurement. Well, and to digest that, you have to chew a bit about it. And I will leave that as an exercise to you. I've talked to you about at least 3 important parts of DDD, the Ubiquitous Language. We want to take the language from the domain and put it into the software. And then we have tactical design, DDD in the small. We take the work objects and turn them into classes and methods. And we have strategic design. We're not building just one big model, but we're splitting up the domain into bounded contexts and build models in the software, modules in the software for that. Okay. And now I have to take a look at the time, and this means I have to come to an end. The hour that we have together is nearly come to an end. There are other interesting topics as well. It's interesting to look into the tactical design more deeply. There are these so-called building blocks like entity and value object. That's something that you may like to look at after this talk as well. So, but I think I have you told the most important stuff. And of course, in 60 minutes, it feels a bit like here. We have to go fast to look onto all these topics. So what now? What's the next thing to do? And one thing is there are different meetups all over the world. These here are meetups from the German-speaking DDD community, but there's an Italian DDD community that's very vivid as well. There's also a virtual DDD meetup. Plus, in this time of pandemic, it makes no difference if you where you live. You still will be in the meetup like we're here now. So it's also interesting to look into other countries as well. What else is there to say? If you want to look at a real example for an implementation of DDD from starting with domain stories to coming to an implementation in the end, then the Leasing Ninja may be interesting for you. If you like to know more about DDD in a workshop, then I'm available for a workshop. This is my workshop, DDD Concrete. It's usually done in 3 days. There are open variants of this, or I do this in-house for customers all over the world. And I would like, of course, to do it in Italy as well. Also, I'm doing consulting. When you have a big ball of mud that should be split up, then it's good to have some help. And if you want to read on after this talk, what's the literature? speakerdeck.com/hschwendner. There you can find these slides again. I think they should be in the Q&A as well. I posted there for a start. And then, of course, there's the Big Blue Book. This is something like the Bible of DDD, where it was described for the first time. Eric Evans is the father of all this. The problem with the Big Blue Book is it's so big and 800 pages, hard to digest. So if you don't have long time, then I would suggest that you have a look at this. Domain-driven design distilled. It's only 100 pages by Vaughan Vernon. If you want to look at domain storytelling, there's a book that I am writing with my colleague Stefan. It's called Domain Storytelling, and you can buy it online on Leanpub for $15. But not for you. For you, it's cheaper. If you use this CodeGen coupon, then you can get it for 33% cheaper. So take a picture now with this QR code here or with this short URL. Okay, and since I'm making advertisement here at the end, I also want to do advertisement for something good, and that's blood donation, especially in this Corona time. There is your blood required, so don't forget to donate your blood. And now I'm near the end. I say thank you, and that's it. Happy end. And I'm here for questions. Please put them into the Q&A. And of course, that's also the way to, I don't know, clap your hands or whatever. Okay, yes, please, if there are questions, please post them now. Okay, I can see no more questions. Organizers, do you see more questions? Okay. I see one from Stefano, who says, thanks for the session, really helpful. Glad to hear that. I hope that's the case for everybody. And yeah, well, if there are no more questions, then I would say thank you and have a good, more conference day, a longer conference day, and maybe enjoy your lunch if you haven't had it. And thank you. Goodbye. Ciao.